Hi all, welcome to my channel. In this video, we're going to discuss about one of the most important video called copy on array list internals, how exactly it's basically working, how exactly it's providing a thread safe over the traditional array list. So in the previous video, we discussed about concurrent hash map internals, and we also implemented the simple concurrent hash maps with the help of segmentations and node objects. If you missed the video, I'll put the link in description, so please go and watch. And also I have uploaded like more than 10 videos on basically on concurrency in the YouTube. Anyway, I'll put the link in description, so please go and watch. So without any further delay, let's start about copy on write array list. What exactly is copy on write array list? What is its variant? How it's basically providing a thread safe. So copy on write array list is the thread safe variant of array list. So I think we all know array list, right? Array list is a traditional dynamic array data structure where basically a traditional array it has a fixed number of array size. Copy on this array list basically contains will provides the will basically endless space. Nothing but it's like basically kind of a infinity, right? Initially they have some default value, for example 8 or 16. So later, depending on the load factor or later depending on the number of values we frequently inserting, it's basically multiply its value. So simple analogy is basically if the load factor, for example, the percentage of values we inserted is more than 75%, right? For example, if I take a 10 values is the default one. So if it has a 75 as a percentage, if more than 8 values are basically inserted, it will basically multiply its value from 10 to 20. So that's how internally the array list will work. Now basically we have add, set and get operations in the array list. So these are like a not thread safe operations, which means you concurrently cannot modify the values while accessing, which will throw the concurrent modification exception. So same in the traditional hash map also, but the concurrent hash map is basically taking care of that one. So now here we'll basically see how it's avoiding the concurrent modification exception, and also how we can basically implement our own basic version of copy on array list like. So this design strategy allows, so the main crux is basically making a fresh copy of the underlying array. So every time whenever we're performing these update operations, right, it will create a fresh copy. So which means the updates happening on the fresh copy, but the original copy is intacting. So while accessing, we'll basically access the original copy. So if you're modifying the original copy, right, we'll get this concurrent modification exception. But here what's exactly happening, we are every time whenever performing an add operation or a set operation, we are basically cloning that object and we are performing the add operation, set operation on top of that. But the original, but whenever someone performing the set operation like get operation, right, for them it won't get the modification exception because they are working on the old operation like. So that is the exact jinx of this copy on write array list. So this design strategy allows us to achieve the thread safety without the need of synchronization read operations as well. Thus significantly improves the read performance in a concurrent environment. There are some drawbacks also there. As I said, every time it's storing a data, right? So some memory overheads is there. Let's see. Okay. Now let's define how it achieves the thread strategy. Later we'll discuss about use cases and also performance overheads. So it's an immutability of state during iteration. So as I said, whenever you modifying the list, add, remove or set, this is basically called as update operations. So copy on write array list creates a new array. So with the changes, leaving the original array unchanged. This is the main crux. So during this operation, so this ensures that iteration over the list elements will always happen on the old values only, but the new data, which is basically new object creating, right, that's basically perform this update operations. This ensures that iteration over the list elements will not throw concurrent modification exception because the iteration is iterating over the array snapshot that exists at the time of iteration creation. This is the main important, like it works on the snapshots. So we'll see in demo also in depth, you'll understand even more better. So and also the other important thing is basically it's using the volatile array, which means the changes will be visible to all the threads. So the internal array of copy on array list is marked as a volatile, ensuring that any thread accessing the array sees the most up-to-date version of the array after another thread has modified. So these are the two main important things. One is basically achieve the immutability by creating a copies, and second one is basically volatile array. And what are the use cases, right? So whenever you perform a read intensive situation, you have a very less frequent writes, but you have more reads. So that's where this copy on ArrayList will works like. So best suits for environment where you have a far more reads than writes, such as caching scenarios where once you load the initial data, reading a frequent and modifying are rare. We'll see why modifying is not a good why modifying more modifiers is not a good for copy on ArrayList. And also iteration safety. Ideal for scenarios where you need to iterate over a collection without locking or risking the concurrent modification exception. When you're iterating and you're doing some operations, update operations, if you don't want concurrent modification exception, this is the best choice. Now let's see about this performance considerations, right? Main thing is basically it improves the read performance tremendously. Since reads can occur without locking and thus the not blocking by writes, read operations are very fast and scales well. Now write performance, right? So each write operation requires copying the entire underlying array, which can be expensive in terms of both CPU and memory usage. So every time you need to copy, you need to store that value, you need to add a value or set a value, remove a value, and completely override the new value object with the old value object, right? This is the performance overhead when it comes to write performance. The need of copy the underlying array and each modification can lead to significant memory overhead, especially for large list. So 10, 20 list or 100 list is not a big issue, but when it comes to millions of data, right, millions of values in an object, that's definitely a performance issue when you're basically doing more writes than a read. If you're doing more writes, then this data structure is not at all good. If you're basically performing a very less reads and more reads, then that is always a good option. Now let's do a simple code of copy on ArrayList. Then you'll understand better like how we are basically copying every time. So okay, here only let's create a custom copy on write ArrayList. So what exactly it requires? It requires an object. Okay. So initially assume, okay, let's define a constructor. Public custom ArrayList. As I said, it's every time it's basically defining the creating a new object, right? While creating a new copy, right? While performing the all update operations like add, remove, and set. There is no need to give the initial default capacity as well. You can just still give, but it doesn't require like new object. Let's have a default capacity 0 only. There is nothing is there. Now we have basically public. We have basically two things, right? Public void maybe add operation and so add operation will takes the element, right? Let's have a generic. Let's give a values more generic way. Let's create a constructor as well. And what else you required? And while adding, while performing this update operations, you require a locking. So let's have a reentrant lock. Reentrant lock. Oh, cool. Now let's perform. Let's declare other two operations as well. For add, set, remove, and also get. So what exactly this add operation will have? So first basically take the locking. So lock it dot lock. You are performing a lock operation. Now let's create a arrays dot copy of original array, nothing but object. Original array, you have copied original array, and you have incremented a size object dot length plus 1, and you have sent to the local variable. and you perform a new object dot you perform new object dot for timing. Let's give a name as array only, it's too confusing of object. So let's have an array dot length new array of array dot length equals to you're passing an element, and then you're basically overriding array equals to new array, and in the finally you are basically performing the unlock. You got it right? So every time we are basically creating an object and then only we are adding like. Now set will require the index also. Now let's copy same thing. It always looks exactly similar. Lock array new object instead of array dot length. So here we are not adding any extra value, right? That's why we don't require a +1. So new array and you're performing on index operation, index an element, and you're overriding the array. That's fine. This is work fine. So initially you have to check the constraint. The maybe index is always index should always be less than array dot length. That condition you can check. Otherwise you can just simply return, or you can basically throw exception also. Basically index out of bound exception, whatever you want, like, yeah. And while remove operation also you need to perform index, right? You want to know which index you want to remove. You don't want an element. So here also almost similar. So here what exactly you required, you need to reduce the -1. Here you are not assigning anything. Here you need to first copy the index, copy the values from 0 to that index, whatever index you passed, and then index -1 and index +1. We need to skip that particular index. So we have a systems dot array copy. So it will see object. So what is the object you are performing, and source and destination, our new array, and destination position, and also length. So these are the 5 parameters which are very important. So systems dot array copy, right? System dot array copy. So we are performing on an array. Source position till index on a new array. So first thing is what you need to perform, right? Till up to index, just copy paste. So systems dot array copy, you are basically copying a new array from 0th index, comma, you are performing on old array, right? Array, comma, new array from 0 to till index. Is ready. Now you need to skip the that index value. Systems dot array dot copy from an old array, index +1, just skip that value on a new array, index comma array dot length minus index, array dot length minus index -1. Yeah, so basically we are basically performing from 0 to index, and we basically skip that particular index +1, and we rest all the values we moved from index position to the array dot length till array dot length, and we are returning, and once we got the new array, and we are assigning to the old array, and we are removing that value. This is how remove operation will work. So we have one more thing, simply public void public e get operation, right? Get of particular index. You can simply, it's a simple operation, array dot get of array dot get of index, array dot array dot index value. Yeah, this is a simple get operation. Yeah. So while implementing this one, you can simply implement a main method, copy on ArrayList example, custom ArrayList example. For now, I'm passing integers only. List equals to new copy on ArrayList. So he can perform list dot let's say list dot add 1 for integer, list equal for integer value in list, integer value in list, I think we need to implement the iterator also, right? Okay, cool. Anyway, that is not required. We can implement traditional way without iterator. Let's have the size also. We can expose the size method also. Public int size return array dot size, array dot length. So now for int I equals 0, I less than list dot size I plus plus. Now you can basically perform, let's say, list dot for example system dot out of println list dot maybe get of I. Here let's try to add a value, list dot add for example 2. For now let's execute. Yeah, actually every time it's basically adding, right? But if you see, it's not basically throwing the congruent modification exception. So basically if you see the run, right, see it is not throwing any congruent modification exception because it is basically presented in the while loop. It's keep on adding. So we can basically exit if basically list dot size is greater than 5. Break. Let's perform break statement. Yeah. Now let's quickly do for ArrayList once. ArrayList integer ArrayList equals to new ArrayList for integer value equals to ArrayList. Before that, let's insert a value, ArrayList dot add, right? ArrayList dot add 1. Now here you basically copy the same one, ArrayList dot get sorry, you can just print the value only, and here you're basically doing this ArrayList dot add value, and ArrayList is size greater than 0 here. If you see, this is basically throwing a concurrent modification exception. So ideally, right, if you implement the iterator in the custom copy ArrayList only, we can build the same thing. We can basically simulate the same thing like instead of traditional for loop. But the idea is basically, even though after implementing the custom iterator also, if you perform this operation on top of this one, it will not throw the concurrent modification exception. Like that is the benefit of using this custom copy on array, like copy on a write ArrayList, where every time we are basically copying the stuff, right? Copying the original array into the new array, and for get access, it is still accessing the original old array only. That's why it will still invoke as it is like. So we can also check, for example, existing implementation of copy on write ArrayList. Yeah, copy on write ArrayList. We can just go inside and see the let's see the add op. Let's see the add operator. See, it first has a locking, and it's basically doing the exact this copy, right? Exact this copy and setting array and return the true. It's basically returning the boolean. I'm basically returning the void, right? So we can, that is nothing we can still do like. So but exactly it's internally happening. It's same thing, arrays.copy of. It's also doing arrays.copy of, right? So same for all the operations. Like for example, add. Maybe let's see remove. Remove is a kind of complex, right? So remove also, what exactly remove is doing, it is doing exact system.array.copy only, like how exactly I have done. So here also it is doing the exact same thing, right? So this is a simple version of implementing the copy on ArrayList, which will basically thread safe one, which will prevent the concurrent modification exception while accessing and keep on modifying the existing object itself. So this is the one of the example. I hope you got something from the copy on write ArrayList, what is internals, how it's internally working. So that's it for today's tutorial. In the next video, we'll basically see one of the most important concepts in concurrency framework, that is basically features, callables and completable features. We'll discuss more in depth with examples as well.